Okay, what do you already know about it? Any idea?
Kinetic means movement.
Okay, very good. And what are we referring here by particle? What do you mean by particle? Can you tell me how many particles are there?
No,
No?
the atoms.
Okay, atoms. Anything else that is called as particle?
Molecules,
Yes, very good. And anything else?
ions.
Well done. Very good. Yes. So these three kind of particles we will be referring whenever we are talking about the three states of matter. This will be referring these three particles and of course their movement. That will be based on different factors that we are going to see. It's a theory that speaks about the particles in matter. Can you define a matter? What is what is matter? How to define matter?
Uh, Anything that we can see.
We cannot see, and it has some space and has some mass. Anything that occupies some space and has some mass, it is called as matter. And all the matter around us in this universe is made up of small particles. This is what the theory says. The theory that we are going to learn, it says that every matter in this world, in this universe, is made up of small particles, and we cannot see them with our naked eyes. It is only possible if you would like to see them through some kind of microscope, maybe electron microscope. And this theory also tells about the spaces between the particles in all matters. This will discuss about the difference in the space, amount of space they have. However, we will see what difference is there in the three states. This theory also talks about the constant random motion about of the particle, but obviously the three states will have different speed of movement, and that is something that is differing all the three states with each other. That is making a difference between the three. The theory also talks about the amount of kinetic energy they already possess. There is an energy that is provided from outside, and there is an energy that they already possess. That is their energy content. We will talk about it later. So this theory talks about this energy is also, it talks about the change in kinetic energy it will have when we will provide temperature from outside. So it's variation with the temperature. And the most important point that I would like you to learn for all times, that is that whenever you are talking about the absolute temperature, when we say temperature, when I'm saying that something has a high temperature, I mean that the average kinetic energy of the particle is higher. If I say temperature is lower, I mean that the average kinetic energy of particle is lower. That means they have less energy of movement. They are moving with lesser energy, so they have lesser temperature. This is just a summary of the theory, and we will look into each and every postulate of the theory in detail with reference to the three states. Thinking that you have covered some of the stuff in your junior classes, as well as obviously before me you have been studying, I assume that you must be having some of the idea of all of this, but let's do it quickly so that I could take you to the assessment part where I could check you how much you understand and how much is still remaining from understanding. All right. When we talk about arrangement of particles, the words are important to understand. Arrangement means we are talking about their placement in a particular area. So when I say the solid particles are closely packed, the liquid particles are also closely packed. But what is the difference in their placement? That they are orderly arranged, whereas liquid particles, they are closely packed, but they have a disorderly manner in clusters. Like if this is a liquid particle could be found in cluster form, whereas solid particles are closely packed in individual form like this. However, in liquids, you could find some space in a very random type of arrangement. All right. In gases, you do not say that they are closely packed.
Okay.
Something that is making them different from solid and liquid, that they are placed very far apart from each other. And what is matching its arrangement with liquid is its random manner. Again, if it's the same container, you are going to take solid, and if the same container you are keeping a liquid, and if it is the same container you are keeping a gas, you will see that particles have no regular arrangement. They are just randomly arranged apart from each other. However, for solid, it's a very regular arrangement. Can you give me an example of solid? Yusuf, can you hear me?
Yes.
Can you give me an example of solid where we talk about the particle arrangement in orderly manner?
A mug.
Metals? You said metals?
Mug.
Oh, mug is an object. Did you say mug?
Oh, you want me to name me like an element?
Yes, from the elements. Something that should have a solid state at room temperature. So metals we have seen in our periodic table, these are metals which have the arrangement like this. Can you name one element which has a liquid state? An element.
H2O.
Sorry, I could not hear you.
H2O.
I said element. H2O is a compound. No?
Yes.
So do you know the placement of solids, liquid, and gases in periodic table?
Not really. Yes.
Okay. So starting from this area to this, these are all metals. Just a random introduction. We will do periodic table in detail later on. But for every part of the syllabus, periodic table introduction is important. So I'm just giving you a general introduction. So when all of them are metal, obviously they all are solids. However, there is an exception of mercury, Hg, that's a liquid. Francium is another liquid in the periodic table. It's a metal of group 1, but it is also a liquid. So here you have two liquids. One more liquid you will find in non-metal area, that is bromine. This is also a liquid at room temperature. So in your periodic table, there are 3 liquids. And if I talk about gases, starting from nitrogen, oxygen, fluorine, chlorine, sorry. and this group 0 or group 8, these all are gases. Clear?
Yes.
Now, whatever is left here in the periodic table, they all are solids. So you have a very limited number of elements in the periodic table. You will have to learn under, oh, sorry, I forgot hydrogen. Hydrogen is also a gas. So a very limited number of elements which are having liquid and gaseous state. Other than that, all of them are solids. So all those which are red in this periodic table without shaded line, they all are solids. Now coming back to, it's just a general idea, and I'll keep giving you this revision. I'll keep asking you this thing. It's very important. Okay, then why they are arranged this way? The particles have this arrangement because of certain factors. First factor is the force of attraction between the particles. So let's say I'm talking about the metals. So what is the force of attraction between the metals? What is the force of attraction in the metal, which is very strong? That is basically a metal's positive part, and there are some free moving electrons in a metal that are held together by a very strong electrostatic force. So that is a very strong force which keeps them together, doesn't let metal ions go anywhere else. Now, when you talk about liquids, whether we talk about bromine liquid or mercury liquid or water liquid, the force is basically existing between the molecules. This area that I'm coloring with red, this is the area where the force has been applied. And we call it intermolecular forces. So in liquids, you will always find intermolecular forces and not the electrostatic forces. I'm just introducing, do not worry about the type of force I'm giving you. I'm just relating your concepts here with every kind of state of matter which is there in the syllabus. However, generally, you should learn generally that metals have, solids have strong, very strong force of attraction between the particles. Liquids have a weak or moderate kind of force of attraction. So we have used two adjectives here which are making it different with each other. One says very strong and one says only strong. This means it shows you the intensity of the strength. Very means it is having more force of attraction between the particle than liquid. And yes, the most important thing is the force between the gaseous particles. This is almost non-existent. So we consider that gases do not have any force of attraction. Gas particles do not attract each other. That is why they are just far apart from each other. They do not attract, catch each other. That is why they just move further away from each other. And because they do not have very strong force of attraction, that is why they do not stay at one place, and this is why it is causing their arrangement. So main reason of the arrangement is the force of attraction between the particles. Then comes the movement part, which is actually the basis for theory evolution. It says that particles which are there in solids which are tightly packed with each other, since they do not have spaces in between them, they can't move around, so they just vibrate about a fixed position. Vibration and fixed position. These are the two keywords you have to learn whenever the movement is asked. Similarly, for movement of liquid also, you can use word vibration. However, here you do not find any movement, but their vibration and movement is processed throughout the liquid. So movement is there in the liquid. Random movement is there in the liquid throughout. And here the word throughout should be learned throughout the liquid, whereas here you say movement anywhere. So no movement throughout the liquid and anywhere. These are the three words you will have to learn for the movement. Okay, so what is causing them move faster? What is causing them move slower and vibrate? Is their energy. The solid ones are very lazy. So they have less energy to move around. Liquid ones have energy more than solids, so they are moving little faster than solid particles, and they have enormous energy, so they move all around anywhere with that high amount of energy. Over here, I just would like to ask you a question. If I take out their energy out of them, the particles which are around away from each other, and if I am able to take out their energy away from them, do you think they will be converted into the liquid?
Sorry?
I said, if I am able, let's consider these are gas particles. The two particles I've drawn, these are gas particles, and they have
Okay.
a lot of energy between them. If I am able to remove this energy from them, it has its own energy, and they have stayed away from each other. They have moved further apart. If I take away their energy, do you think they will be converted into liquid with lesser amount of energy?
Yes.
That means if I even take further energy away from them, they can also convert into solid.
Yes.
This tells me that every time when I'm going from a change of state from gas to liquid and liquid to solid, I will have to take away their energy, take away. And if I'm going from solid to liquid and then liquid to gas, then I will always have to give them energy. Is this point clear?
Yes.
Now coming to the density thing, the density is, can you tell me what is density? How do you define it?
Uh, how much there is of something in a particular space?
Okay, to elaborate this, I could say that it could be mass per unit volume. How much mass or particles are accommodated in a particular volume. So for example, if these are three states with me, and I know that this is a solid state, this is liquid, and these are gaseous particles. So if I consider that volume is same, let's say volume is 2 centimeter cube, 2 centimeter cube, 2 centimeter cube. What do you think the mass is? Is it same for all?
No.
So the mass over volume for solids is more as compared to mass per volume for liquids. So since mass is more, the density is more. This relates the concept of higher density. Since particles are closer together in the same volume, there are more particles accommodated accommodated as compared to the liquids and gases. Liquids are also considered as higher in density as compared to gases. However, they have lesser density than liquids. Again, their particles are also closer together. And the density in gases the lowest.
Okay.
Okay, since the particles do not have space over here, we cannot compress them. You cannot compress them further because there is no more space. Here, I would like to tell you an interesting fact. For liquids, technically, they have space and you can compress them. But for that, you actually need a very higher pressure, which basically is not possible. So in books, again, I say in books, you cannot compress them. So if it comes in exam, we will always write no. But if it is for real, you can compress them actually. But since we are talking about our IGCSE syllabus, so we will have to stick to this rule. It says no, no. Here we have a lot of space, so we can compress them a lot. Now, there are certain past paper questions related to your concept. Do them quickly. Keep giving me answers quickly so that we move on to the next concept, that is the change in state of matter.
One only. It is A.
Okay. Next.
C.
In which of the following are the particles arranged in a regular pattern?
C.
Right. Next, number 3.
A.
Now you see why I told you about the states of matter, because when you would know from the periodic table that it is they are talking about hydrogen, and you would know that it's a gas, then only you could tell me this part. All right. Next. Okay, this is from state of matter. Just let it be. We are not solving it. Here, actually, I have just brought a past paper question for you to quickly look at the type of question. It was a 3-mark question where they have simply asked you to place a tick or a cross to describe these properties. We know that if it is a solid or a liquid, particles are closely packed. That is why they are touching each other. In gas, they are not closely packed, so they are not touching each other. We know that gases and liquids have random movement, but solids do not have any movement. We know that the regular arrangement we see is there in only solids, whereas in liquids and gases, they are not regularly arranged, but they are randomly arranged. This is the question from specimen of 2023. If you know that 2023 was the year when the syllabus was changed, so they had sent a specimen paper where they were Just giving us an idea that what kind of questions can come. Here they are using separation word for the placement of particles. So how do you call this? You see, there are two confusing words, separation and arrangement. So here you will talk about the space, whether they have space, whether they are touching or they are tightly packed, they do not have space. And in arrangement, you will tell whether it is a regular arrangement or a random arrangement. Do you understand the difference between two?
Yes.
Okay. Motion, we will talk about vibration only. Since they are talking about solid state, that is why here we are saying it's vibrating only. Again, they are giving 3 states of matter, and then they ask you about the particle separation. They are touching or they are, or you could even simply write they are tightly packed. Even if you don't want to write touching, you can write tightly packed. But since the question itself has given this word touching, that is why I have used this word touching here. Otherwise, even you write tightly packed, that is correct answer. The arrangement, since they are giving 2 words to me, whether the arrangement is regular or random. I know liquids have a random arrangement, so I will pick random and I will write it over here. They are asking me for the type of motion, and the 2 words they have given themselves is vibrate only and random. I know the movement is random in gases. So this is how I am picking up the keywords for the answer. Now, the next thing that we are going to cover is the change of state. How can we change one state to the other state? The 3 states that you have seen, solids, liquid, and gases, they can be interchanged to each other by the transfer of energy. And that is what I discussed in the first part of the topic, where I told you if you remove all the energy, you can go back from gases to liquid and to the solid. And if you increase their energy, you can move forward from solids to liquid to the gas. However, there are 2 things that you need to understand. When I say solid is being converted to liquid, the phenomena is called melting. Freezing is when liquid go back to solid. This is called phenomena. But when I have to perform this phenomena of melting or freezing, what action will I take? What I will have to do to solid that it converts to liquid? What should
Melting.
I do?
Increase temperature.
Increase temperature by heating them? Yes?
Yes.
How will I increase the temperature? I will have to heat. So something that I have to do, the action I will take will be heating. What I will have to do if I want to go back, I want to make liquid going back to solids. I want freezing to happen. What action will I have to perform?
Cooling.
Cooling. So only these 2, heating and cooling, will be repeated all over for all the 6 stages. Melting, freezing, heating, cooling. Here, if I go from liquid to gas, the phenomena is boiling, the process is boiling. But what I'm going to do is heating. And when I go back from gas to liquid, what I am supposed to do is cooling. However, solid to gas and gas to solid, both way we call it sublimation. So if you want to say sublimation from where to what state, then you have to mention. Sublimation from solid to gas, that is called For that, what you have to do, you have to heat. And sublimation from gas to solid, you have to cool.
What is the difference between sublimation and deposition?
Basically, sublimation is deposition is used for the same this state. But here in your syllabus, they have not used this word deposition. They say, but just use sublimation for both changes. However, the gas converting to solid, we use deposition. If you have done it in geography, you must have studied this whole phenomena. Have you done that?
No,
Geography,
we are not taking it.
the rain cycle. Anyways, so we are not bothered to learn that because it's not there given by our course. That's why we are not bothered to learn that and the differences between the two. But what we need to know is that they have used same word for both the changes, whether solid to gas or gas to solid. They have the same meaning or same phenomena they are referring to. Clear?
Yes.
Okay. Now here again you have a past paper question. Quickly name the process for me. I will write here for you and then we will move on to heating curve explanation.
Melting,
One is melting.
condensation,
Number two is condensation.
freezing,
Freezing.
evaporation.
Boiling, not evaporation. You need to know this, the difference between evaporation and boiling. Evaporation is a change that occurs even at, or you can say at all
Surface of the liquid.
temperatures. Okay. However, boiling occurs at only boiling point. So while you are referring these three states, these three physical changes with reference to the state change, that means every time you are performing that action of heating and cooling. Heating, cooling, cooling, which means the fourth one cannot be something where you have not performed any action and it occurs at its own. You can't refer evaporation. That means all of them have to be in according to the processes that you are performing, according to the action that you are taking. You cannot out of the sequence say that it is evaporation, because evaporation will be either at room temperature, maybe you have not heated it and it has evaporated it itself, or maybe it is occurring at boiling point. So basically evaporation is a large, long term, a bigger term under which comes these two changes. Is that clear? Is that clear, Vita, Yusuf?
Yes.
Okay, now with reference to this concept, I'm going to give you the idea of the substances that are going to change from one state to the other state. And this is learned through this curve, a graph which is drawn between the time and temperature. Temperature we keep on y-axis and time is kept on x-axis. Mostly time is always on x-axis. And Here we are referring water as a substance that we have picked. And we are going to look at the temperature change with reference to time. Meanwhile, we will also look at the change in the state, and we will see the reason of certain state changes at each and every point. Let's say water you have present is at minus 20 degrees centigrade. You know that water freezes at 0 degree centigrade, freezing point.
Yes.
And what is boiling point? 100 degree centigrade. Freezing point means if you cool it till 0 degree centigrade, if you have cooled it to 0 degree centigrade, then it will become solid, that is ice. And if you keep cooling till minus 20 degrees centigrade, it will not change its state. It will still remain solid. So we have solid water, that is ice, at minus 20 degrees centigrade. The class is going to be over in 1 minute, in less than 1 minute. So I have another link that I'm sending you so that you can immediately join through that link.
Okay.